Right. What? Bringing everything. Around this side. Thank you for those people. You're welcome. Yes. I love this. It's like my perfect size. Yeah. You know what? The common is like the average, I feel bad for the so like my daddy's John. Is it because of Harry's? How would you like break? That's like my least favorite thing to combine. We watched the video and this dude was 6 points. He was huge. Our friends were blonde, like turned around, it was red hair. So we take selfies, but like, we'll take pictures of you too. Not with you, that's of you. That's concerning. They don't have Facebook. I feel famous. But you would have, yeah, if you follow like it sometimes ago, you would be taking many pictures of. Just once I was like using the blog, you're allowed to go to the what? The Sanderson sisters and Hocus Pocus. You got the yeah, you can see one of our friends. I'm not a blonde. There's a redhead. You're the redhead. Maddie can pull off the blonde. You're the redhead. I get to write it on the weird, crazy one, and then Madison is I'm dyeing my hair blonde. When I got my haircut, I was like, oh wow. Yeah. Well, my hair does swell, and you have to wait till they grow more and get them. 99% of it is. Oh yeah. But everybody. Yeah, I was playing with my sister and my friend, and I found like the camper had like a small boat. And I was like, wait a second. And it took it apart. I was like, wait.
All righty. So let's go ahead and get started. Mark and Kinsley today. So we'll try to keep that. So let's go ahead and take a look. So like I said, factoring test. Hopefully I've gotten everybody's test. Polynomials corrections test. Factoring extra credit in pages 160 and 162. Okay. So we've got that taken care of. Now today we're going to be kind of continuing on with factoring. So we're actually going to be working in on page 70. Let's see, it's lesson 78, page 171. Lesson 78, page 170. Okay, so in lesson 78, page 171, notice it says a rational expression. Sound
Ratio.
Ratios are fraction, okay? Take it a rational expression is basically, and so it's a fraction. Numerator and denominator are both polynomials. We've been working with polynomials. We have multiplied polynomials and we have factored polynomials. So these are things that we have. Main difference with a rational expression, denominator. Okay, so now instead of just having one polynomial, I have two, which we're going to be doing the exact same thing with factor, except for because a rational expression is a fraction of the rational expression, but never in the denominator of an individual polynomial. All of the rules that apply to simplify fractions apply to simplifying rational expressions. So when I'm simplifying a fraction, if I had 12 over 24, what can I do with that? Divide by 12, that's 1. Divide by 12, that's 2. So that's 1/2. So whatever I have in the numerator, if I have a similar thing in the denominator, and the reason for that would be if I was listing out prime factors, that would be 2 times 2 times 3 over 2 times 2 times 2 times 3. So those 2's cancel, those 2's cancel. What did I miss? Oh, and my 3's, okay? So basically, remember that as these cancel, that just means they're becoming 1. And 1 times 1 is 1. And so that's 1 over 2, okay? So that's kind of the reason behind when we cancel, that's basically what we've done. It's just a whole lot more work to have to list out prime factors and cancel each prime factor. So we've learned to do it dealing with larger numbers. But what we're going to be doing, in essence, with these situations is first we will factor our polynomials in the numerator and denominator, and then we're going to look at canceling. So I have the same rules that apply with rational expressions as we do with fractions, that basically if I have something in my numerator that can be canceled with something in my denominator, I can do that because dividing 3 by 3 makes 1. Okay, so we're going to be looking at things that follow that same rule. Second sentence says, be careful when dividing by a variable. A variable represents an unknown value and could cause you to divide by 0, which is not allowed. So in your book, I want you to underline that divide by 0, which is not allowed. Why not divide by 0?
Because the answer is unknown.
My answer is undefined. Okay, so when I say divide by 0, like if I had 2 divided by 0, that is undefined. Okay, I cannot divide by 0. So basically, if I've got a fraction, if I've got a variable in my denominator, what if that was 0? Then that would be undefined. Okay, so what we're going to have to start looking at is what could make my denominator 0, and we have to state those as exclusions. So look at the next sentence. It says, whenever you divide a factor containing a variable, you must determine what value will make the factor equal to 0 and state as part of your answer that the 0 causing value is excluded. So go ahead and underline again in your book that starts with you must determine what value. It's the last sentence starting after the comma. You must determine what value the factor equal to 0 and state part of your answer that the causing value is excluded. I'm going to be calling these exclusions. Okay, so in a minute, I'm going to make a list, step process. This is what you do first. This is what you do second. This is what you do third. And one of the last things that we do is state exclusions. When I say exclude, things that make a variable in denominator a 0, because I cannot multiply by and I cannot divide by 0. So anything that would make a number in the denominator, we have to make it as an exclusion. Okay. So let's go ahead and look at the example, or actually, let's go ahead and just do our notes real quick. So steps in a process, if you just want to jot these in your textbook, if you want a separate piece of paper, whatever you want to do. I think I'll go to this side of the board because I have to do that. So simplifying rational expressions. Step 1 will be to factor the numerator and denominator. Step 2 will be to cancel like terms. Step 3 will be to simplify solution. And step 4 will be to state exclusions. Now, one of the things I'm going to focus on right now is this step 1, because think about, we just finished up with factoring. And remember, the first type of factoring we looked at was we learned how to factor a common monomial. So we've done factoring common monomials. We've done factoring the difference of two squares. We factored perfect square trinomials. We factored x squared plus bx plus c. Blood's rushing on my arm. We factored ax squared plus bx plus c, and we did ax squared plus bxy plus cy squared. Check. Sure. So when I talk about step number 1, factoring the numerator and denominator, it could be one of any of these things right here. It could be factoring out a common monomial. It could be factoring the difference of two squares. It could be factoring perfect square trinomials. It could be factoring x squared plus bx plus c, ax squared plus bx plus c, ax squared y, no, ax squared plus bxy plus cy squared. It could be any of these things, okay? So a factor, numerator and denominator. Then we're going to cancel like terms. Then we will simplify our solutions, and we're going to talk more about that in just a minute. That's what we were talking about, like with fractions, where I can cancel what's in the numerator and denominator, and then we have to state our exclusions. So let's look at the example they've given us. If I start with, this is the example, 2x plus 2 or x plus 1. Okay, let's look at the numerator, and which of these type of factoring do plus 2. What can be factored out? What do both terms contain?
2.
A 2. So we're going to factor a common monomial. So I know that a 2 can come out, and what is left? X plus 1. Now notice what's in my denominator. That is already simplified as possible. There's nothing that can be factored out. But now look and see what is the same in my numerator and denominator. X plus 1. Now, one of the things I need to make sure you understand is I cannot, let me say this again, I cannot separate something that is joined by a plus and minus, okay? You cannot, I can't cancel X and X, okay? Separate these two. I have to cancel this as a complete term. X plus 1 cancels with X plus 1. Not simpler. I cannot simplify by pulling them apart. If they are joined by a plus or minus, they have to stay together. Okay. So we'll be looking at some examples to deal with that more in a minute. Okay. So now remember that this is the same as dividing, as this would become a 1. That's a 1, right? So sometimes I may need to remember, especially if I canceled all of my numerator doesn't just go away. It would just be a 1. But what is left? 1, so my simplified solution is just 2, okay? So when I look at this, I started out, I factored out a common monomial. So I have 2 times x plus 1. Then I looked and said, hey, the two terms can cancel because they are exactly the same. What would happen if this was a minus and this was a plus? Does that mean they're exactly the same? Nope. So there's nothing I could do, okay? But once I canceled, I can see I've got 2 over 1, which is equal to 2. So we have factor. We've canceled like terms. I simplified my solution. That's what it means, where I looked at what's left in my numerator, what's left in my denominator, and I simplify my solution. Now my final step is state exclusions, okay? So what that means is I look at my denominator before my final answer, just my denominator. What could X not be right here? What could X not equal would make this 0? What number would I have to plug in here for this to equal X plus 1 to equal 0? So basically saying X plus 1 cannot equal 0. Okay, so if I was going to solve this and I had 1 and I took away, then X can equal -1. Does everybody understand that? So X could not be -1 here because -1, 0, and I cannot divide. Okay, so this is my exclusion. So for every answer, I'm going to have a simplified solution. I have an exclusion. Okay, these are going to be uncomfortable at first. Get on, you're going to be just fine. Okay, how much do I see here? So I'm going to have 1 exclusion. If I have 2 X's in my denominator, I will have 2 exclusions. If I have 5 X's in my denominator, which I promise you, I would have 5 exclusions. Okay, so the X's in my denominator will determine my number of exclusions. And we're going to look at the different types of exclusions that we can have and just below that went through. Factors can be canceled and separate X plus individual terms. They cannot be separated. It has to stay together as an entire expression. And then it simplifies to be 2 because we cannot divide by 0. If the values of X are excluded, set the factor in the denominator. There's no problem not solve for X. And so we can see our exclusion is -1. So our practice work, okay? So the first one is 2X or 6X. So the first thing I look at is there anything that can be factored in the numerator or the denominator? No, because I just look at X, X, but there's nothing that I can pull out. And then I've got 6X squared. So again, the only time I factor is when I have more than one term. So if there's single terms, there's nothing to factor. So I move on to canceling like terms. So in this situation, okay, what operation? Multiplication. So basically this is like 2 times X and this is 6 times X times X, okay? So when they're like this, can cancel. When they're like this over here, I cannot join together with a plus or minus. I cannot separate. If it's multiplication, I can, okay? So basically, what is 2 and so I divide both of these by? 2 and 2 divided by 2 is, and 6 divided by. So I can see that I've got 1 over 3 now. What about X and X squared? What is my rule when I divide variables with exponents? What do I do with those exponents? I subtract them. So it helps you to remember that this would be X to the first. Okay. So what is X to the first? So that would be X to the first minus 2. Okay. So remember, when I have a negative in the, so in this situation, all I'm going to do is cancel my X here, and this one becomes a 1. Okay? Is everybody good with that so far? So now I've canceled. Now, one of the things, a lot of times when I look at this, things can get lost, really. So you don't miss something. What did everything? So I have to have, if I've got a fraction, I've got to have a numerator. Okay, so if everything has canceled, it's 1. 3 and x. Okay, simplified. Everybody good with that? All righty. So now that we've simplified, remember, I've got to look back at my denominator to determine what x cannot equal. Okay, so if I think about what number, when I multiply, anytime I'm multiplying and I have an x in my denominator, and it's either a number times x or just x by itself, what can it not equal? What did we say is undefined? I cannot divide by 0. So basically I'm saying 6x squared cannot equal 0, right? So if I divide by 6 and divide by 6, x squared cannot equal 0. Therefore, x cannot equal 0. So in this situation, x cannot equal 0. Everybody good? So for the first one, we divided, we simplified. We have our simplified solution. We have our exclusion. Okay? Let's look at the next one. All right, the next one is 6x squared plus 4x over 3x plus 2. Okay, so let's think about step 1, factoring. One of the things that I always start out with is I go ahead and draw my fraction line. That helps me to remember I've got 2 different things to factor if I can. Looking at my numerator, right now, ignore my denominator. What can I factor out of 6x squared over x? 2x. I can factor out 2x. So what is 6? I have a plus sign. What is everybody comfortable with how we factor to the numerator? Now let's look at the denominator. Can I do anything to that? Is there anything I can factor out of both of those? Nope. So it just. Now, so this is the part where I go, okay, I'm on the right track. And why? Because I see that I've got something in my numerator that's the same in my denominator.
You can cancel that.
I can see that 3x plus 2 can cancel 3x plus 2. Remember, I can only cancel them if they're identical. Okay, so 3x plus 2 cancels with 3x plus 2. So now what is left in my numerator?
2x.
2x. Simplified answer. How many x's? Hey,
I was told to ask you to turn up the thermostat.
there we go.
Thank you.
You're welcome. Okay. How many x's do I have in the denominator? 1. So how many exclusions will I have? 1. Now, this one is not as easy to see as this one is. Okay. When I'm looking at this, could I say if x is 0? Because what would 3 times 0 be? 0, but then 0 plus 2 is 2. So that does not give me a denominator of 0. The way I can set this up is to say 3x plus 2 cannot equal 0. So this is the way you can always do exclusions if you cannot. I'm going to teach you a way to see it in just a minute. But if you ever are confused and not able to figure out how to do exclusions, just always set up whatever it is and put it cannot equal 0 and then solve for x. So in this situation, I would subtract 2 from each side. So 3x cannot equal -2. Divide by 3, divide by x cannot equal -2. Okay, my exclusion there, x cannot equal -2/3. Now what I want you to look here, what is this sign?
Positive.
What is my exclusion? Positive or negative? Negative. Got 2 over, so I have opposite sign. And then I take this number that is after the plus or minus, that becomes my number. This number here is my denominator. So every time you're stating an exclusion, terms joined by either plus or minus. The number after the sign is the numerator. The number at the beginning is the denominator. So that's how I state my action. Okay. So remember, 1x to my denominator, 1 exclusion. Quickly. Just know that when you're gone during the middle of class, y'all are missing stuff. All right, the next one. I have x squared minus 3 over x squared plus x minus 2. What is step? Factor. I'm going to go ahead and draw my fraction line because I've got to factor my numerator and my denominator. So remember, this is going to be the situation where I say, okay, I know that I'm going to set up my parentheses. What is my first term going to be? X. What do I know my?
Positive.
What does this one tell me? Opposites. The larger is positive. So I'll put a plus and a minus. Now I'm looking for numbers that multiply together to make -3 and add together to make +2. What are my only factors of 3?
1 and 3.
1 times 3. So which is going to be the positive? 3. Okay, so we factored our numerator. We've got to factor the denominator. I'm going to set up my parentheses. I know my signs will be opposites, and the larger will be positive. So I'll have x plus x. What are my factors of 2? 2. Which one will be the positive? 2, because the larger is positive. On the right track. Go.
Because 2 makes sense.
All right. Get to the point where I factored, I start canceling. I start simplifying. And remember, I can only cancel when they're exactly the same. So in this particular example, I can see that I've got x minus 1 over x minus 1. Those two can cancel. So simplify my answer. I have x plus 3 over x plus 2. Remember, I cannot separate when they're joined together with a plus or minus, so I cannot separate. I can't cancel x and x, okay? I cannot cancel these two right here. I have to leave these together as entire terms. So that's my simplified answer. This is where I'm going to go to look for exclusions. How many x's do I have? 2. So how many exclusions will I have? 2 exclusions. So x cannot equal. I'm going to start with this one, okay? If I have x plus 2 cannot equal 0, what does it mean x cannot? Positive or negative? Negative 2. If this was a 2, 2 plus 2 is 4. I'm good there. But if it was -2 plus 2, that's 0. So it cannot be -2. So what I'm doing here is I'm taking the opposite of this number. So for this one's exclusion, it's going to be the opposite of this number.
And the other one would be x cannot equal -3.
No, this is a 1. Okay, so what's the opposite of -1? Positive 1. So I put a comma and write my number. Okay, so we found that my answer, my simplified solution, is x plus over x plus 2. Remember, I only find exclusions only for values of x in the denominator. I don't have to do it for the numerator because I can divide into 0. I could have a numerator of 0 and not have a denominator of 0. So basically, if I plugged in -2 here, what is -2 plus 2?
0.
So in each of these, if I plugged in -2, and I said -2 plus 2 is 0, and then what is -2 minus 1? 3, what is 0 times -3? 0. So do you see that if I plugged in -2 here, it's going to make my entire denominator 0. Same thing if I plugged in a +1 here. 1 minus 1 would be 0. 1 plus 2 would be 3, but 0 times 3 would be 0, so it wipes out the whole denominator. Okay, so that's why I have to have an exclusion for each value of x in my denominator, is because by the other term, denominator makes it 0. Thumbs up, thumbs down. How are you feeling about this so far? Kind of sideways. Hey, at least you're sideways. All right. Grant. All right. So yeah. So right now, I don't expect you to be like, yeah, I got this. No, you shouldn't have it. Okay. We're gonna practice with it some more. How's everybody feeling about factoring? Thumbs up, thumbs down on factoring. Okay, so we just had a test on that. Hopefully you're feeling, hopefully your thumbs up on fact. That what we just did our test. Canceling like terms, thumbs up, thumbs down. Are y'all canceling fractions? Like behind practice them. Good. Solution, we're just looking at that and stating the main is a half. And the number of exclusions will depend on the number of x's in my denominator. Okay, so I'm going to go ahead and erase over here, and we'll go with the next one in our classwork. So we have x squared plus 6x plus 9 over x squared minus 9. Now, one of the things that hopefully at some point, it'll be the more you work with them, you'll kind of start recognizing some of these special patterns that we talked about. The difference of two squares and perfect polynomials. This one. What's the square root of this one?
3.
If I have 3x plus 3x, what does that equal?
6x.
6x. So I can see that this is a perfect square trinomial because when I factor it, I'm going to have x plus 3 times x plus 3. Now again, I can factor it just like I did x squared plus bx and say my first terms. I know mine will be the same, both be positive. Times what is 9 that adds together to make 6? 3 plus 3. What is this one? The difference of two squares. So I know I'm going to have x plus something and x minus something. And what is that something?
3.
3.
Whoa.
So we have the numerator, we have factor. What can cancel?
X plus 3.
X plus 3 can cancel because they are identical. Notice I have x plus 3 in the numerator, x minus 3 in the denominator. So I cannot cancel those because they have different signs. So what is my simplified answer?
X plus 3 divided x minus 3.
Good. X plus 3 divided by x minus 3, or x plus 3 over x minus 3. Now I've got to go to exclusions. Remember, exclusions go to step before canceled. So I'm looking at here x plus 3 and x minus 3. So what do I know that x cannot equal?
3.
3 or
-3.
3 or -3. So putting it, I could have like that, or I can have that, where I have plus minus if it's the same number. This just means +3, negative. It's just a shorter way of writing it. It's up to you. Or you can write it as a negative and a positive. But again, I have two x's, two exclusions. Okay. Questions so far? Real quick, let's do a quick result by types of exclusions. Okay. Remember, if I had an x by itself in the denominator, or if it's being multiplied by a number. If I x that's by itself or it's being multiplied by a number, my exclusion is always 0. Okay. If I have a number, whatever my terms are, I have a number times something as something, take the opposite. Second number is my numerator, first number is my denominator. And then something plus something minus, take the opposite of this number, the opposite of this number. So those are my rules for stating exclusions. That's going to be the patterns that I follow for each of my exclusions. If it's an x or sometimes x, it's going to be 0. I'm going to have a fractional exclusion. It looks like it comes to the opposite of each number. So let's practice with these. On activity 2, notice that we're just canceling here. So go ahead and start on activities 2 on page 71. All you're going to be doing is simplifying. You're looking at what you can cancel. I'm simplifying. Let's look at the first one. When I'm multiplication, so so 3 and 12. How can I simplify this?
By 3.
By 3. 3 divided by 3 is
1.
And 12 divided by 3 is
4.
4. And then x squared. What happens to my x in the numerator?
The x in the numerator with the x in the denominator stays.
That one cancels. But this one comes to an exponent of 1. Okay, so what do I have left in my numerator?
1.
1 over what's in my denominator?
4x.
4.
Comma. 0.
Okay, so what is my exclusion for this one?
0.
X cannot equal
0.
0. Okay. What about our next one? What does my 5 over 15 reduce to?
1 over 3x.
1, 3. X can't. That becomes x to the first. I have 1 over 3x. What is my exclusion?
0.
Again, it's just going to be 0. Can cancel between 4 and 20.
4.
4 divided by 4 is 1. 4 is 5. X squared and x cubed. It cancels. What does x cubed become? X to the first. So I have 1 over exclusion.
0.
All right. Everybody good with that?
Yeah.
All we did was cancel on those. And each of those had a number in my denominator where I was multiplying by x. So that means x cannot equal 0. Okay. Let's go ahead and turn over to page 172. Page 172, we are going to work on the left-hand column. I'm going to top to bottom. So this is page 172, activities 3. If you want to go ahead and number these, let's go ahead and number them top to bottom. So 1, 2, 3, 4. Okay, so we're gonna 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Top to bottom. So this will be number 1. 3x squared plus x over 3x plus 4. All right. When I'm looking at these, I start with my numerator, and what can factor out of 3x squared plus 4x? X can factor out. So if I factor x out of 3x squared, what do I have left? 3 what?
X.
X. I'm factoring an x out, and it's 3x squared, so I'm going to have an x left.
Plus 4.
Plus 4. What is my denominator going to be?
3x plus
3x plus. I can do there. What I have in common, numerator and denominator, I cancel. Chad, do I need to move you up here? There's a stair. So I can cancel. I have left numerator. X. Is it necessary to put over? Here's my simplified solution. Where do
3x
denominator? So I wrote my simplified answer. How many x's do I have? I have.
1.
So cancel. What is my pattern when I'm here? Opposite sign. So what's my exclusion going to be? Negative. This my numerator. Denominator.
3.
There's my exclusion. When I see something that looks like this, I'm going to have a fraction exclusion. Take the opposite sign. Number after the sign is my numerator. The number at the beginning is denominator. So basically, put in -4/3 3 times, and actually, I'll just go ahead and show you. 3 times -4 over plus 4 cannot equal 0. That's why this is an exclusion. Okay. So if I plug this in, I would have 4 divided by 3. Hang on just a second. I would cancel. -4 plus 4 cannot equal 0. So, all right, take a break. Thank you, thank you.
I really
See you later.
Oh my goodness.
My mother taught subject one, and I had to take it as mandatory until seventh grade. Yeah, whenever I was mad, everybody would go to my mom and my sister and be like, "Why is Victoria so mad?"
Hi, you get a first class nerd.
I wasn't first.
Yeah, you were.
Betsy and Zoe were.
No, they didn't leave. Yeah, they never rolled up. They came in here one pick. Does anybody even know where Mark is?
On Zoom.
He's out sick.
I know, but like, why?
He's on set.
Hopefully. Hey, I love Same. I get pizza and it's so exciting. Yeah, this is such a pizza, but I can say I feel like I'm just jealous of all you guys that were on the pizza.
I know. I look like so much different.
I don't put lunch on
I know, I like that.
It's your mask pocket. I mean, like, is your mask in your pocket?
It was
Like
like
everyone's
5
pockets
seconds
that comes out.
You just like should like extra.
Man, you guys really analyzed that 2 seconds I just talked.
All right.
Do you think I have to do?
So we just saw where we have 3x squared plus 4x divided by 3x plus 4 simplified to x times 3x plus 4 over 3x plus 4. We were able to cancel 3x plus 4 because it was both in the numerator and the denominator. So our simplified solution is x. And our exclusion is x cannot equal -4/3. Okay. The next one, 12x squared plus 22x over 6x plus 11. Let's look at the numerator. What can factor out of 12x squared plus 22x? 2x. So I factor out 2x. This is why it's important to remember that whatever you're factoring out goes at the beginning of your parentheses, okay? So 12x squared divided by 2x is 6x. My sign is a plus. X by 2x? 11. And I go, hey, look at there. I've got 6x plus 11 in my denominator. So what can cancel? 6x plus 11 cancels. So what is my solution? 2x. Okay. What is my exclusion going to be? What can x not equal?
-11/6.
Yay, -11/6. And there's your answer. Okay. Why do we have to state exclusions?
Because.
Because it says 2. Why does it say 2? Because the denominator cannot equal 0. Good. All right. Number 3. Number 3, I have x squared plus 3x minus 4 over x squared.
Plus 2x minus 3.
All right. So I know I'm going to have to factor. I'm going to go ahead and set up my 2 sets of parentheses. I'll go ahead and do it in the numerator and denominator. If I know my signs will be in my numerator. I'm going to have opposite signs, so I'll go ahead and put a positive and negative. What about my denominator? Same thing, positive and negative. In this situation, the reason I like to kind of put them in the same order is because then I know that if these 2 can cancel, they're already stacked on top of each other. Same thing here. What is my first term going to be of my factors in my numerator? They're both going to be x's. Good. So I'll put x and x. Now I have to find factors of -4 that add together to make a +3.
Positive. -1 times 1.
Okay, so think about 4 is going to either going to be 1 and 4 or 2 and 2. Those are only options, right?
4.
So 1 and 4, and which one is positive?
4.
4 is positive, so I put my 4 there and my 1 there. Okay, if you need to write it out step by step, that is just fine, just like you did with factoring. Okay, if it's starting to become a little bit easier for you to say, okay, factors of this that add together to equal this, then some of this you might be able to start doing in your head. Same thing here. I need factors of -3 that add together to make 2. But first of all, what are my first things in my parentheses? I know I've got x's. What are factors of -3 that add together to make +2?
-1.
-1, +3. What can cancel?
X minus 1.
X minus 1 cancels. So what is my solution? What is my numerator?
X plus 4.
X plus 4 over
X plus 3.
X plus 3. Exclusion.
1 and -3.
X cannot equal. Remember, I have to go down here. I have 2 x's, so I'm going to have 2 solutions. The opposite of +3 would be -3. The opposite of -1 is +1. So I just write those with a comma between them. And there's my solution. Okay. I'll erase and put number 4 right here. All right, number 4 is x squared minus 9x plus 20 over x squared plus 3x minus 28. Okay, this one's going to be a little more challenging as far as our factoring goes. We've got some bigger numbers we're dealing with here. And it's the same thing where, remember how when we started factoring, we said the first thing we always ask ourselves is, can I factor out a common denominator? So that's going to be where I always start. Obviously, if I start with just x squared, I know there's nothing I can factor out of every single one of them. But that's going to be where I start each time, is looking to see, can I factor anything out? Do I have a common denominator? But if not, then I go ahead and start it. So I always start out, set up my parentheses. What do I know my signs of my numerator are going to be? Both will be negative. Good. And what do I know the first terms will be? X and X. Both of these are going to be opposites. So I'll have X plus X minus. All right. So like I said, I kind of like to get this stuff out of the way, but now I go back up here. I'm looking at factors of 20 that add together to make -9.
-5, -4, -4.
-4, -5. Good. So I know that -4 and -5 make a +20 when I multiply. But when I add them together, -4x plus -5x is -9x. What about factors of -28 that add together to equal 3?
-4 and +7.
-4 and +7. Good. All right. Now, also, one of the things I want to mention here is when I'm up here, I know that when I'm looking down here to be able to cancel something, I'm hoping that one of these is either going to be negative x minus 4 or x minus 5. Okay. And I can tell that it's not going to be x minus 5. So if you get stuck and you're trying to figure out, ooh, what is that factor to be? I can't kind of let this be a guide for you to help you say, well, my goal is to be able to cancel. So hopefully there'll be something I can cancel out. So go ahead and say, what if I had x minus 4, what would my other term be? And that may help you kind of go a little bit faster. So I can see x minus 4 cancels with x minus 4. So what is my simplified answer?
X minus 5 over x plus 7.
So there's my simplified solution. Now I'm coming back to this middle step here. What do I know that x cannot equal? -7 and +4, because I just looked at the opposite of each of these numbers. And there's my answer. Okay. I want you to work on the middle column right now. Okay. If you finish that, you can go on because the last column will be homework. So go ahead and work on the middle column so I can come by and answer any questions that you may have. I'm sorry. The last row, depending on, go ahead and do it in the book. Okay. You can do it in the book. If you would rather do it on paper, do it on paper. If you need space, if you feel like you can't fit it, then do it on paper. But you can do it in the book if you can fit it in. Okay. If you have questions, let me know so I can come help you. I know I'm going to have a fraction answer because come up here and I want you to write 3x plus 4 cannot be negative. I want you to solve for x. What would you do? What would you do first? So we're going to pretend like this is an equal sign, okay? But what would you have to do to undo this problem? What would you do? Remember, we do reverse compass. So I'm going to undo addition and subtraction first. What is being added? Good. So on the other side. That's it. Good. Remember, it's got to be on either side of my equation. Okay, so if you took away 4 on this side, what do you have to do on this side? Good. So what do you have left over here? 3x. Okay, so copy on, you have 3x below it. Now, how do I separate 3 and x? Good. 3. So let's cancel what the next one.
But I don't know what.
That's the reason why we did the shortcut is I just take the opposite sign. Whatever my second number is becomes my numerator. My first number is my denominator. So that's my shortcut. Okay. The reason is because of this. All right. So good job. Uh-huh. Okay, so if there's not a common monomial that can come out, then I'm going to set up my 2 sets of parentheses. Okay, what are my signs going to be? Good. What will my first term be? All right, now I need factors of -12 that add together to make a +4. So think about my factors of 12. I've got 1 times, 2 times, 3 times. Okay, so if I think about 1 positive, 1 negative, the larger will be the positive. Which of those will add together to make a +4? Okay, so which one should it be?
Wait.
Which should be the positive? Good. Good. Okay, so now in the denominator, I've got to set up my 2 sets of parentheses. I have the difference of 2 squares. So what do I know my signs are going to be? Remember the difference of 2 squares. I'm going to have 1 positive, 1 negative because remember it cancels out that middle term. Good. What what's the square root of 4? Very good. Fantastic. Good, keep going. So again, I'm just going to go ahead, if there's nothing that can factor out of all of them, go ahead and set up your equal sign. On the fraction bar. Okay, now go ahead and start factoring. Set up 2 sets of parentheses.
Yeah.
This one tells me my signs will be opposites. Okay, my second sign is negative. I don't want to have opposites, so one will be a positive, one will be a negative. Okay. What will my first term be? Okay. All right. I need factors of negative 12 that add together to make a positive 4. Okay. So think about what times what makes 12. So I have 1 and 12, so I have negative 1, positive 12. What are those add together make? Negative 1 and positive 12. 11. Okay. And then I can have 2 and 6. I would have a positive 6, negative 2. What are those add together make? There it is. So which one was my positive? Remember, solve the logic. Good. That was 6. Next then. Who's that? Good. All right. Now we've got to break this one apart. Okay, there's nothing that can factor out of both of them. So I can see this. Can I find the square root of x squared? What's the square root of x squared? Just x, right? Because x times x is x squared. What's the square root of 4? Okay. So this is the difference of 2 squares. So set up your 2 sets of parentheses. When I have the difference of 2 squares, what do I know about my signs of these? The opposites. Okay, so what's going to be my first term? And what's my second term? What can cancel? Good. What's my I was gonna say, I think I have one in my bag from last
Just
year.
have like a pack of 300.
Lovely, lovely. Okay, now, real quick, we need to say our exclusions. What was your exclusion here? Go ahead and put x cannot equal. Okay, what would my exclusion be for this one? The opposite sign. Okay, that's my exclusion gonna be here. Opposite sign. Second number over first number. Good. Exclusions here. What can X not do here? In this one, when I just have X plus something or X minus something, I just take the negative of this number. Or take the opposite of, okay? So what is the opposite of 2? What's the opposite of 2? What's the opposite of positive? Okay, so there's a negative 2. And what's the opposite of negative 2? So 2, negative 2, comma. So those are my exclusions, okay? Good, we'll keep going. We're going to factor, cancel. Okay, so just remember, you need to write your final answer somewhere. You've got your exclusions. Oh, okay. Okay, so what did you cancel here? So you're good. So you have x plus 6 times x
Yeah, I
minus
was
2.
doing
I think I guess you just hear your x and your minus. So what cancels here? Okay, so what do you have left? Over. Your exclusion was right. Oh, no, I'm sorry, it's not. Okay. So x cannot be here. Okay, what can x not be here?
Negative.
Good. Don't really dash to a comma, because since we're not, so on that one, x can, cannot be -2. What about this one? Good, okay. So you write your simplified answer, so whatever is not canceled becomes your simplified answer, and then your exclusions. Okay, so do the same thing for the last one. Okay? Awesome. This is only the difference of 2 squares. So what's the square root of x squared?
I
That's
need to
really
focus on which one,
and what are my signs gonna be?
which one we pull out.
One positive and one negative. Yeah. So you have x plus 2 times x minus 2. Okay. And then, let's factor this. Like I said, just at the
Is it really?
and this one tells me my signs will be.
You know what? Okay, I'm gonna watch it.
So that's my first term in the mix. Now, I need factors of -12 that add together to equal +4.
Yeah. And even the second one.
And which one's gonna be my positive and my negative? How last I think here. Good. Now I need to do exclusion. X cannot equal what?
How old is
If we're, x cannot equal based on these two. Okay, so go ahead and put x cannot equal. Okay. Now, what could x not be and would make this 0?
No.
I take good. Yeah, so -2. Okay, no, this one.
Miss Jane, can I get the doctor? Oh, I see it now.
Okay, so when you factor here, right? What can x not be? You guys, the answer should be -1 and -8. Good. All right, let's get ready and go over the middle column. All right, middle column, starting with number 5. All right, so number 5, we have 6x plus 10 over 3x plus 5. All right, what factor out of my numerator?
2.
A 2. And so 6x divided by 2 is 3x. And 10 divided by 2 is 5. Good. And I can see that this is already 3x plus 5. There's nothing that can simplify there. So I cancel. And what is my solution?
2.
All right. What can x not equal? -5 over 3. Take the opposite sign. This becomes my numerator. This is my denominator. So there is number 5. Any questions? 6. 14x squared minus 21x over 2x minus 3. All right. What can I factor out of 14x squared and -21x? 7x. 14x squared divided by 7x. 2x. I have a minus. 21x divided by 7x. 3. So I can see again, I've got 2x minus 3 my denominator. Those are going to cancel. What's my solution? 7x is my solution. Look and see, do you have 7x? And x cannot equal
3 over 2.
3 over 2. Take the opposite side so it becomes positive. So there is number 6. Questions on that one? Number 7, I have x squared plus 4x minus 12 over x squared minus 4. Bless you. All right, there's nothing I can factor out, so no common monomials. So I'm going to set up 2 sets of parentheses here, 2 sets of parentheses here. What do I recognize this one as? The difference of
2 squares.
2 squares. So I know I'm going to have a plus and a minus. And I know that I'm going to have the square root of x squared is x and x. The square root of 4 is 2 and 2. So there's the easy part of that one. Okay. Now, I'm going to start factoring this one in the top. What do I know my signs will be? Opposites. One will be positive, one is negative. And I know my first term will be
X.
I'll have x, x. I'm find fact to make a positive 4, negative 2. What can cancel?
-2 and
X minus 2 can cancel. So I'm left with x plus 6 over x plus 2. Now I need to do my exclusions. How many x's do I have? How many exclusions will I have?
2.
What are my exclusions?
2 and positive 1. I mean 2 and positive. 2 and positive. -2.
Good. I'll have a -2, positive 2. So I can either write it as positive -2 or I can write it separately. So there is my solution. Questions on that one? Number 8. All right, x squared plus 10x plus 16 over x squared plus 9x plus 8. Any common monomials that can factor out?
No.
Nope. Set up my parentheses. What do I know my signs are going to be for all of them?
Positive.
Oh, they're all positive. All right. First terms are all x. Okay. Factors of 16 that add together to make 10.
8 and 2.
8 and 2. Factors of 8 that add together to make 9.
8 and 1.
8 and 1. What can cancel?
8 and
X plus 8. So my simplified solution is x plus 2 over x plus 1. What can x not equal?
1, -2 and
-1 or -8.
-1, -8. Take the opposite of 8. That's -8. The opposite of 1 is -1. Okay. So your first bit of homework will be numbers 9 through 12. So this is page 172.
Can it be in the book?
9 through 12 in the book. Now, I will be checking these on Thursday. Okay? You will get a 0 through 4. Okay? You're on your homework grade. If you've done all 4 of them, you'll get a 4 out of 4. If you've done 3 out of them, it's a 3 out of 4, which is a 75%. 2 out of 4 is a 50%. Obviously, 0 out of 4 is 0%. Okay? So you will get a score, an effort grade. I will be looking for a simplified solution as well as exclusions. Okay, so I'm going to be looking for them to be simplified solutions, exclusions. All right. Grant, put it away, please. Let's go ahead and look at lesson 79. Lesson 79. Now remember, what did we say that we follow the same rules on these as with our canceling, our simplifying and all that stuff? What did we compare these to? Because they are types of what?
Ratio? They're types of fractions.
Good. Ratios are fractions, so my rules apply. What do I know about adding fractions?
You have to have the same denominator.
Okay, so if I'm going to add, and let's say I have 3/4 plus 1/2, what do I have to do first?
Well, you have to have them have the same denominator.
They've got to have the same denominators. To add or subtract, I have to have common denominators. Okay. So typically when I find common denominators, there's several things that you can go about doing. The first thing I look at is, can I use one of these? Okay. So my first step is, can I use one of the denominators that I have? Can I?
Yes.
Yeah, I can use which one?
Let's use 4.
The 4. Okay. I have to go with the larger of the two, and if I can use it on both of them, then I do. So how do I get from 2 to 4 multiplying? What do I multiply 2 by to get to 4? I have to multiply by 2, so that means I have to multiply my numerator by 2 also, right? So now I have common denominators. I've made equivalent fractions. So there's my solution. Okay. Same thing with subtraction. If I had 1/2 minus 3/4, again, I could set that up as 2/4 minus 3/4. 2 minus 3, -1/4. Okay. Common denominators. Now, what if I had something like 1/2 plus 1/3? How can I find, can I use 2?
You have to,
No,
Can I use 3?
No, you
both
could add
of
them
them.
to get, you could multiply them together and get 6.
I can multiply them together and have a denominator of 6. What do I multiply 2 by to get to 6? So if I multiply this one by 3, I have to multiply my numerator by 3. So that becomes 3/6. What do I multiply 3 by to get to 6? Times 2 is 6, times 2 is 2. So I can add. What if I have 1/12 plus 3/8?
Can take stuff from the bottom and put on the top.
Never mind.
Never mind.
I'm going to start canceling.
So first of all, remember in this one, I said, hey, I can look and see about using the larger one. Same thing here. These ones said we just multiply them together. Could I multiply these together and find a common denominator? Yeah, but what is it going to be?
Big.
96.
Oh.
Because 12 times 8 is 96. Okay, so I'd have a really big number. Could I do that? Yeah. What else could I do, Sadie?
Could you divide 12 by 3? Like crossways?
No. The reason I cannot, I'm glad you asked that. The only time if I had, the only time I can cross multiply or whatever, go in crossways is if there is an equal sign in the middle. Okay, that's the only time I can do anything across, whether it's canceling or multiplying or whatever. Okay, if it's a plus sign, there's nothing I can do there. Okay. What are my multiples of 12? 12, 24,
Oh. 24 would work.
36, 28. Remember least common multiple?
28.
What times 8?
20.
Okay, let's think about 8. 8 times 1,
8
times 2, times 3.
24. No.
Did we already say
68.
24?
Yes.
What's my common denominator?
24.
My smallest common denominator is going to be 24. Now, in just a minute, we're going to look and see that we can still just multiply them together. But what do I multiply 12 by to get to 24?
2 by 2.
So that means I have to multiply my numerator by 2. So that becomes 2/24. What do I multiply 8 by to get to 24?
3, so 9.
So I have to divide, I multiply by 3. So that's 9. So I end up with 11/24. Now, again, I said, hey, I could multiply. And I could say this is 96 and this is 96. What do I multiply 12 by to get to 96? 8. So what's my numerator on that one?
8.
And then what do I multiply 8 by to get to 96?
12.
So I have to multiply this one by 12. What's 3 times 12?
36.
Now I've got over 96. I've got 36 plus 8 is 44. Now, what am I going to have to do this?
That's a simplify.
What am I going to have to divide by to simplify?
12.
No.
4, 2.
How
about you divide by 4?
1.
4.
Remember, I'm looking for the largest number that will divide evenly into both of them, and it is 4. 44 divided by 4 is 11. 96 divided by 4 is 24. So to get to simplest form, I have to be able to simplify, which might be a challenge. It will, I mean, at the very least, take more work because you're gonna have to get out your calculator and, you know, try to solve. Okay. So by going ahead and starting with your smallest common denominator, you're gonna have a smaller number to have to simplify if it needs to be simplified at all. Okay, so that's the main reason about using smallest common denominator when you're dealing with fractions. All right. So keeping in mind that we are dealing with fractions, but our fractions are a little bit different because we've got polynomials we're dealing with. But when I add and subtract, my denominators have to be the same. So let's look at lesson 79 on page 173. Page 173. Okay, first of all, let's read the lesson, and it says, when adding or subtracting rational expressions, follow the same rules for adding or subtracting fractions. You may only add or subtract rational expressions that have a common denominator. Simplify the answer if necessary. As in the previous lesson, you must state exclusions. Underline that. You must state exclusions. The last part of that first paragraph.
Yeah.
So basically in this one, I have 1 over x plus 2 plus 1 over x plus 2. Now think about when I have 1 over 2 plus 1 over 2, what is my denominator in my answer? 2, because I keep my denominator, right? But what do I do with my numerators? I add the numerators. Okay, so this is for lesson 79. 1 must have common denominators. 2, add the numerators. Keep denominator the same. Okay, so I add my numerators, but my denominator stays the same. Okay. So in this situation, my common denominator is x plus 2. So what does that mean? My answer will be in my denominator.
2x. X plus 2.
Did I add these together? Did my denominator become 4?
No.
Nope, I keep it the same. So my denominator is x plus 2. It stays the same. If this one is x plus 2 and this one is x plus 2, then my answer will be x plus 2. But what do I do with my numerators?
We add them.
Add them. Okay.
Can you do that where you simplify?
Okay. So can I do that where I simplify? Can I split these apart? No, these are stuck together with a plus. Okay, remember if it's with a plus or minus, I cannot split them apart. I can only cancel numerator and denominator if they were being multiplied in the denominator. If this was 2x, then yes, I could cancel my 2's. But because these are joined with a plus sign, I cannot split them apart. Okay. So now it says because a variable appears in the denominator, you must state an exclusion as part of the answer. So I'm going to go ahead on step 3 and put simplify if possible. Step 4, write simplified solution. And then step 5, state, that would be state exclusions. Okay, so here's our simplified answer. What can x not be in this problem?
2.
What's 2 plus 2?
4.
Could I have 4 in the denominator?
Yeah.
What could I not have here? -2. The opposite of this number is my exclusion. Okay? So let's look at classwork. All right, so classwork 1, 1 over x minus 1 plus 1 over x minus 1. Are my denominators the same?
Yes.
So what will my answer, what will my denominator be in my answer?
You did.
And what is my numerator? So there's my answer. What is my exclusion? What can x not equal?
1.
1. Okay, so we said 1 over x minus 1 plus 1 over x minus 1. Keep my denominator the same, add my numerators. There's my solution to my exclusion. The next one is 2x over, and this is all the classwork, 2x over x plus 3 minus x plus 5 over x plus 3. What is my denominator and my answer going to be? X plus 3. Now look at this one. I'm going to have my numerator and I'm going to have 2x minus x plus 5. Okay, so I started 2x minus x plus 5. Remember, step 3 says simplify if possible. So instead of add the numerators, I'm going to put add or subtract. Okay, what is 2x minus x?
X.
Negative
X.
x. 2 negative x.
1.
2 x.
2x minus x.
Negative x. 2 negative x.
Is it negative?
It's x.
X.
2x. Think about this. X is 1x, right? So 2x minus 1x
Oh.
is going to be x.
Oh.
Right?
We knew it. We knew it.
I have 2 x's and I give an x away. What do I have left?
1.
1x. Okay, so if I had 2 x's in my hand, I need to get some little x's. If I had 2 x's in my hand and I gave one away, I'd only have 1 x left. Okay, so 2x minus x is x plus 5 over, keep my denominator, x plus 3. There is my simplified solution. What is my exclusion? X cannot equal -3. Okay, I take the opposite of that number is my exclusion. So now let's look at activities 2. All it says is state whether or not each problem can be solved as written and explain why. Okay, so we're saying yes or no, and if it's no, why not? Okay, so I'm going to go across the top row. The first one is 5 over x plus 3 plus 2 over x minus 3. Can I solve it as it's written?
No.
Why?
Because the signs are different in the
Signs are different. They're not common denominators. So the first one is no, not common denominators because different signs. All right, look at the one next to it. 4 over x plus 4 minus 4 over x plus 2. Can it be solved as is?
No.
Why?
Different numbers.
Different numbers in my denominator. So no, denominators are not the same. One is plus 4 and one's plus 2. You don't have to write that then. Look at the third one on the top. 5 over x minus 4 plus 7 over x minus 4.
Yeah.
Yes, good. Denominators are the same, so I could add and I'd have 12 over x minus 4. Second row, first one, x over x plus 2 minus 3x over 2 plus x.
No.
Yes.
Can you just flip
Actually,
it?
yes.
Can you just flip the bottom?
Just say no.
Yes. Yes. No.
I'm all yes.
Yo.
You still don't have 20.
Are those the same thing?
Yes, they are.
Okay, x plus 2 is the same as 2 plus x. Commutative property of addition tells me I can flip flop them. So those are the same. So yes, because x plus 2 and 2 plus x are the same thing. So for number 4, I could do that. All right, now look at the one in the middle.
That is not.
Well, if you simplify it.
Okay, so let's take a look at it and see. First, I do need to go ahead and simplify by factoring. So let's look at it. I have 2x over x squared plus 2x plus 1 plus x over. What does x plus 1 squared mean I have?
X plus 1 times x plus 1.
Good, x plus 1 times x plus 1. All right. Now, factor the first.
2x squared. What?
I know my numerator is 2x. I'm going to leave that. We've just said this is x plus 1 times x plus 1. But I've got to factor x squared plus 2x plus 1. What are my signs going to be?
X, and then 1, 1.
X plus
1, 1.
1 and 1.
I'm writing it for her.
Are these the same? Mhm. Okay, so yes, my denominators are the same. I've got x plus 1 times x plus 1 in both of them. All right, what about the third one in the middle row? 6 over 2x minus 1 minus 3 over 2x minus 1. Yep.
Yes.
Bottom row, first one.
Yeah.
Yes. Bottom row, second one.
No.
No.
Bottom row, third one.
No.
Good. 2x plus 2 is not the same as 3x plus 3. So no. Any questions on
Wait,
those?
why is the bottom middle one there?
Bottom middle, because I have x minus 4 in the first one and x minus 5 in the second one.
I didn't know that was
They do look very similar, so that's why you just have to be super careful, okay? So your homework is going to be the last 4 on page 172 in your book. That's numbers 9 through 12. Tomorrow we will practice with page 174. Okay, not tomorrow. Thursday. It's hard because I always mess up my geometry class. My geometry class is one after the other, so it's Wednesday, Thursday. And so it's always the kind of thing where I'll go, okay, so on Monday, and they're like, we don't come on Monday. So I'm like, oh yeah. So anyway, so our homework is just this. On Thursday, I will check this homework. We will go ahead and pick up with our adding and subtracting rational expressions. And then, yeah. And then after Thursday is spring break. So if you have questions, be sure to let me know so I can help you. Don't forget test corrections. I will give back on Thursday. Just give me your test today. Alrighty, man, that's a super grader. All right, so I hope you'll have a good couple of days, and I'll see y'all Thursday. You guys let me know if y'all need any help with anything.
We got 4 minutes until